I'm here to introduce my friend Gerald Harper. So, Gerald's serious interest in trains started as a child growing up in southern Rhodesia, when every 3 years he would make a 3 day and night train trip from Salisbury to Cape Town, followed by a 14-day ship voyage to Europe for what was called long leave. The trains were pulled by buyer Garrett's. It's okay, Keith. It's okay, Keith. Settle down.
I'm getting excited, Jerry. I'm getting
I know, I
excited.
know. After graduating, Gerald moved to Canada, and he spent his whole career in the mining industry working on projects all over the world, many of which involved either underground railways in the mines or relied on the commercial carriers to haul mine products. After the kids were all grown up, he was able to start on layout construction and, like most of us, had goals to build driven by commitments to display at conventions. The first was in 2003 for the NMRA Maple Leaf Convention. Since then, he has morphed from HO to ON30 to ON3, O, and HON 3.5. Big breakthrough came in 2006 when he bought an office building which had a little bit of excess space. How convenient. So he was able to construct more permanent layouts. Gerald's known about Anyox as a copper mine since the 70s, but it was only an incidental reference that alerted them to the significance of the railway that made the whole operation work. Since then, he has researched it extensively, given several clinics on it at narrow gauge conventions, and in 2023 visited the site to do some archaeological work. Gerald and I, strange coincidence, Gerald and I lived on the same street in Toronto for many years without ever meeting. And he was number 26, I believe he still is, and we were number 46. And we didn't meet until just before he moved out of Toronto. So it was a railroad relationship that never developed. So, Gerald, over to you. You want to share your screen?
The Anyox model railroad. What's the state of construction? This is an aerial view that it must have been taken in just after 1921. Unfortunately, like so many things, somebody put a title on it which was wrong. It's not the concentrator, it's the coke plant. And if you can see my cursor, there's the coke plant. This is the end of the railroad on the dock. The railroad runs all the way around there, all the way along there, and keeps on going to the left. And I'll show you that in the next photo. Part of the significance of this is that you had to get a long way out in the bay before you had deep enough water for full-size ships to come in and dock and stay around during high and low tide. And you can see a ship there unloading coal to be turned into coke. And you can see another ship here, which is probably loading the byproducts from coke. The company that built this project made an absolute fortune. And they did it for two reasons. One was the price of copper skyrocketed when the First World War started and went way beyond their dreams. And secondly, when you make coke out of coal, you end up with a whole bunch of byproducts like gas and tar and benzene and so forth. And they sold all those. And they made more money out of selling it than they did out of having a coal mine in the first place, a coke plant in the first place. So the coal is unloaded, goes up here, goes into the plant, gets turned into coke, and then it goes to a bin there where it gets loaded into another train. Turning around, see the docks keep on coming back into the shallower water. They go all the way around there. And then finally at the far side of the bay, you have this horribly smoky area, which is the smelter in full bore, belching out sulfur dioxide. Okay, the mine operated from 1914 to 1936. And actually, during the First World War, it was the largest copper mine in the empire. And of course, brass, which is used for bullets and shell casings and everything, is 50% copper. So that's where most of the copper went. Initially, they were mining very high-grade ore, which was fed straight into a smelter. But then by 1921, the grade had dropped and they added a flotation mill into the circuitry. And the whole operation depended on ships and trains. because when it was designed in 1910 by the engineers, the concept of roads and trucks and open pits and that sort of thing didn't exist. So you use roads, you use railroads. Eventually, the town ended up with a 3,000 population and all the facilities that go with it. The rail system, interestingly, was all electric, almost all was electric powered trains because they had built a hydroelectric dam and they only used steam tank engines in supporting roles. Here's my schematic done in CorelDRAW of that bay. There's the coke plant that we saw earlier. This is the railroad that comes around here, goes over two rivers, Hidden Creek and Falls Creek, and it ends up at the smelter over here. And with a switchback up through it, it comes up on what I call the High Line. The High Line runs pretty well along constant grade all the way to the mine, which is up off the map. And then there is a low line which comes back down from the mine into the lower tracks. And that was where the flotation concentrator was eventually built. Now, this was a massive moving of materials. And I want to give you a few examples. They mined 1.1 million long tons a year, and 44,000 is the number of rail cars which were loaded based on a 25-ton capacity. So the coal and coke, that was 3,600 carloads a year. Flux was 800, limestone was 440, and copper ingots were 550 carloads a year. So we're talking a lot of material being moved either to the dock, from the dock, or from the mine, or to the mine. It's built in part of a room, 14 by 26 feet on three sides. So it's U-shaped, which you can imagine as being the Granby Bay. It's built at ON3, essentially point to point. It's a hand-laid track wherever it's visible, flex track where it's out of sight on the High Line. It's Digitrax DCC with environmental sounds and some mechanically controlled switching systems. So there's a plan of it. Each of these boxes is 4 feet long. Starts with the dock there, runs through the town, comes to the river mouth. There's a Y there that goes off up to the mine. The red, then the black line is the low line round past the hydroelectric plant, the mill, and the smelter. The high line is the red line around there, and then there is the blue switchback which connects them. When you look at it, taken from a step ladder, there is the, we're looking from the north end, and this is the head of the bay. The layout comes around here. Sorry, it's the other way around. The layout goes, that's the head of the bay there. That's the layout there. And this is the remnants of my office, map cabinets and engineering stuff, all stored in the middle with a little bit of garden gauge track in storage there as well. Looking at it the other way, that's the dock end, that's the mill and the smelter and the switchback area there. And here's a bit more detail showing you the mill, the smelter, and the switchback area beyond it. And a couple of things I built the mill as a standalone module initially, and I was going to put a roof on it, like I did on the upper part. And then I thought, well, you know, with all that detail inside, I'm never ever going to have the roof on, so it's just going to get damaged being stored somewhere off-site. So I said, forget it. I'm not going to put a roof on it. The backdrop, other people have commented, mine is all self-painted. Some of it's better. I tended to use the French Impressionist style of sort of dabbing and daubing, but this area I'm quite pleased with, and you'll see some other views of it. And essentially what you see is a mountainous terrain with all of the vegetation totally destroyed by the sulfur dioxide coming out of that smokestack. Here's the details again. The high line is 10 inches lower than the high line is 10 inches higher than the low line, and the main line track length is 96 feet. Now, the interesting thing is, in the real thing, 11% of all of the trackage was built on trestles or bridges, because there was so much in the way of water and rivers and difficult terrain to carry it over. So I tried to stick to that. So essentially, of that 96 feet, I've got over 10 feet of trestles. And I think you won't see another picture from here on in hardly, which doesn't have a trestle in it somewhere. So now let's take a run along the line. All of the main line had catenary, and when it was on, even on the dock, they did keep it on the back track on the dock rather than in the front track. They did have horses and carts, and eventually they did actually have one or two vehicles in town, but certainly not running in a commercial sense. So when we start at the dock, this is what we see. The dock had a series of these crane structures on them, which ran on their own rails between the track lines, and they served two purposes. They either had a clamshell bucket on them so that they could unload inbound coal or flux or limestone, and if they unloaded out of a ship or a barge, then they would dump it into these bins. One was for coal and the other one was for the clean rock, and then it would be filled into hopper cars underneath. Or alternatively, they could switch that out and use a crane with a sort of a loop system on it, and then they could lift the copper ingots and drop them in, gently place them into the holds of ships. They also did a lot of logging because, of course, the mines used a lot of timber. And after they initially logged off the area around the mine and around the town site and the smelter, then they started building little temporary shoe fly tracks down the sound on flat areas where it was easier to log. And then they would barge the poles up to use in the sawmill. So here's another view of the dock with the tug, which is used to pull the barges, and then some of the stuff in storage. And here you can see the other view of the crane. Interesting, this board here. So when they unloaded a clamshell, then they would slew it around. And if it was not a very expert operator, this would usually smash against that. And I think they discovered that if they didn't have this, half the coal would drop down onto the dock and it would have to be shoveled up. So that's why they put that in place. And here's one of the ships which brought in the coal from Vancouver Island and was going to take out a load of ingots when it goes. The ingots were taken down to Tacoma near Seattle, where there was a copper smelter which had been running since the late 1800s and was the only one on the West Coast. So that was where the final refining was done. And this place here had something like 30 to 35 ships a week docking and unloading and loading. It was an incredibly busy port. This ship, it's very difficult to find ships in O scale. This one's made by Deerfield River Laser, a great outfit. And if you ever need a ship for your O scale layout, I recommend getting one from them. The tugboat came from them as well. You notice that, okay, again, take the lid off the hoist house on this crane, and you'll find that there are winches, electric motors, and all the gearing for everything. So it all, in theory, would operate, and they were all electrically run. and they were run, the electricity was done by using a great big clamp and just clamping it onto the catenary for the overhead wire for the railway. So once you had that clamped on, the electric train couldn't get past it, not without pulling down the pole and coasting beyond it. Now let's take a view, take a bit of a run through the town and round to the smelter. I've set the mine, the whole scene, in 1921, but prior to August, because in August, even though this is one of the wettest parts on the west coast, with rain or snow 220 days a year, they did once in a while have a dry spell. And in 1921, in August, there was a massive forest fire which went through, even though half the trees were already chopped or dead from sulfur smoke. But anyway, that's why it's set in July of 1921. And the other reason it's set at that point is because by that time the concentrator was in operation and the smelter had been revamped so that it was handling a smaller quantity of higher grade feed. Once you get into town, you've got a couple of passing tracks, and this is where the crew gets on. It was a very big operation. You've got something like 2,000 workers which have to be moved every shift from their residences either to the smelter or to the mine. So traveling by people traveling was a big part of it. Here's a bunch of the miners all waiting to go on shift, and here's somebody who appreciates the finer points of being a cowboy, waiting for the store to open. There's the mining company office, which was also the where they paid everybody, and the building to the right is the company store. So the money went out at this door and it came back in again at the next door. And then the government of British Columbia ran the hospital, and you'll notice all of the signage on all of the buildings. I don't know, I hunted for a long time to find an O-scale figure of somebody who looked appropriate for coming out of a hospital. And anyway, finally, Aritzia produces this person on crutches, which I thought was very appropriate. And they even had them painted. So I was quite happy to pay a fair amount of money just to get that. The wagon in the back, I'm not quite sure if that was an ambulance or just a leftover from the horses' days. There's the one truck that did come into town, and imagine what it was for, moving the beer around. And there's the entertainment district with entertainment upstairs and downstairs. And this is where the first of the sound modules is installed. And I'll give you a bit more detail on that later. You'll notice the boardwalk. These were built for two reasons. One is it was easy to do with all the lumber, but secondly, they had boxes underneath them, which were utility corridors, and all of the fresh water, grey water, and other services all were run in these and then fed straight into the buildings, which then meant that they could heat the utility corridor and prevent everything freezing in winter. So there you can have your fine dining. And this is actually not a scratch-built building. It's the first of the ones that you'll see which isn't scratch-built. This was a ready-made building that I think came from MTH. It's listed at the back at the end of the talk. And here's one of the scratch-built steam engines, or semi-scratch-built steam engines, which were used for doing the switching in and around the dock areas. And this was one of two which were 060s, and there were a couple of 040s as well. The interesting thing about them is they all had either two sand domes or one very large one with sand feeder pipes to the front and the back ends of the wheels, because of all the steep gradients that they handled. And secondly, none of them had fuel bunkers on the back. They all had sort of open back ends. One or two of them had little bunkers on the side here, and the water was all carried in the saddle tank. And the reason for lack of that is that when you've got a maximum length of 3 miles, then you just have a heap of fuel at one end and the other end. And when you get to the end, the fireman jumps out and throws in enough stuff, logs, to feed the boiler and keep it going for the next 3-mile run. When you have a town and a community, you've got to have some entertainment. So one of the things I decided that they were doing, that there was a band in town and they had a local gazebo. And when you take the lid off the gazebo, you'll see there's the band, and there's a bunch of enthusiastic residents of the town listening to them, so they must be quite good. Or alternatively, they're relatives and they were dragged along. And underneath this, there's another sound module. These two are meant to be synonymous with the extent of the workers' houses. In other words, they're all exactly the same, except that obviously these people are house proud. They repaint their house. These people aren't. It's getting pretty dirty. These people have already got their firewood cut for the winter, and they've got the laundry hung out. These people haven't got any firewood and haven't got any laundry either. And just beyond them, you have the mine manager's house, which is the biggest house. It's got the fanciest garden. There's a view over the river and the estuary. And other than the fact that the train tracks are right beside it, it needs a cutting of the grass on the lawn, it's a pretty fancy house. And immediately beyond the mine manager's house, you come to the first of the trestles. And this one does actually exist at Anyox, or it did, sorry. It's a Y-shaped trestle, and it becomes a turnaround because there's the other track runs along the other side of the river over there. The tunnels are artist license because that's where it goes off scene. And there's a little bit more detail, and you can see again, hand-laid track, spike down, and all the way around it, of course, you've got these handmade brass catenary supports, and putting in the correct amount of supports to keep the wire sufficiently over the center line of the track that the trolley poles on the electric locos can function is not easy. Parked on the non-used arm of the Y is one of the logging trains with a load that's come down the valley from somewhere, and it's waiting to be pulled into the sawmill. And here's another little creek with a little bridge there and a bigger bridge here. And I surmised that when they were building the High Line, they actually built a temporary track to reach up to it, which went up at about a 6% gradient, which was fine if you were just doing construction, but it wasn't practical as a commercial venture. So that has subsequently now been ripped up, the rails all been removed, and they're cleaning it out. And in the background is where the High Line is there. And Jerry, the two rock types in this area are granite on the right and schist or volcanics, which is the grey rock with the quartz veins in it here, which is what hosts the ore body further up the valley. And there is a little bit of a waterfall here, you'll notice, and again, another bridge there and another bridge there. And like everywhere in this area neighborhood, everything that was a big enough tree was cut down and fed into the sawmill. And of course, these ones would have been the first ones, so they probably went into the ties that were then used for the railway itself. And as you come off that last bridge and you come around here, There's a bit of a landslide with a retaining wall, but again, there's some stumps. That one's pretty rotten, but there's lots of stumps, and there's even a moose that seems to enjoy them. And stumps in O scale are not readily available, but Chris Creighton of Schomburg Models, who doesn't exist any longer, he does, but the business doesn't. He made nice O-gauge stumps, and I bought a set from him and then proceeded to modify them and make more of them and make molds and cast my own, so that I had some very more rotten ones, some with decomposed cores, and some with double cut edges. So it's quite fun building a layout where it's almost more important the trees that aren't there than the trees that are there. And here's a view of the High Line further up that landslide, which of course in winter has the potential to become an avalanche. And when you get round out of that avalanche area, you go past the hydroelectric plant, and then you reach the loco shed, which has got a fully detailed interior. And but the mechanics don't seem to have fixed the hinges on that door, even though they are repainting all the windows and doors. And here's one of the steeple cabs. When they first purchased them, they called them Hidden Creek Copper Mine, which was the name of the ore body, the mine, numbers 10 and 11, because presumably they'd filled up 1 to 9 with steam engines. And but eventually, when they gave them a midlife rebuild, they renamed them Granby Mining Company and still called them 10 and 11. But anyway, that's fairly typical of what they were. And they lasted the whole life of the mine, the two of them, and they hauled an incredible amount of tonnage, as you can see from those numbers further on back. And here's a train of cars waiting to take coke now up to the smelter. There's a couple of passing tracks here, and just beyond them, there's a siding with some flat cars waiting as well to go up to the mine. And here's some flat cars, which are being used to haul the copper ingots from the smelter back to the dock. And here we've reached the concentrator, which doesn't have a roof. And you'll notice that here is the substation with the power lines above it going over to the hydroelectric plant. And there are cables in there which go into the switch room inside the mill. And there's a compressor there to provide compressed air. And here's a better view of the mill. And I'm going to spend a couple of minutes running through this, partly because I like it. I'm very proud of it. And also, somebody started a chat on the IO group recently about what to use for windows. And I use clear acetate. And I must admit, I haven't got into the sophistication of glass slides. But what I do is any type of an industrial building, I always use these very small window pane tissue frames, and I always put plywood over as many of the windows as I think reasonably would have got broken, because I've yet to find any factory anywhere where if you break a window, you get up there with a sheet of glass and replace it. You just throw in a piece of plywood to stop the wind blowing in or the snow blowing in. So anyway, that's my suggestion. When in doubt, put plywood in the window. Moving on, okay. The trains come in at the top. They dump the ore into what's called a grizzly and an ore bin. And from there, it goes down into the primary crusher. The primary crusher then has a conveyor up to an ore bin. From the ore bin, it's slurried and fed into a ball mill. From the ball mill, it goes into a cyclone, which separates the finely ground from the coarse ground. The coarse ground goes into a rod mill to get ground finer, and then it goes into the same flotation cells as the fines have previously gone into. And the flotation cells, there are two banks of them, what are called roughers and then scavengers. And then the copper concentrate is separated out, filtered in a drum filter, and then dried with a hot air dryer. And then the concentrate is then railed up to the smelter. What you don't see in this diagram is the electric breaker room, the warehouse, the washroom, and the locker room, all of which are in the same building. Why is there an electric breaker room? Well, most of the electric motors came from Western scale models. Bill Gustafson made lovely electric motors in white metal castings, and every motor that you purchased always had a little on-off breaker switch with it. And so I felt, well, I had to use these, and they wouldn't have all been right beside the motor. They would have all been in a control room. So I have a control room full of breaker panels. Here's the ore coming out of the fine crushed ore into the slurry tank and then into the ball mill there. The ball mill, interestingly, was made out of a plastic pharmaceutical pill pot with a gear on the end of it, which was acquired from an old dot matrix printer. But it worked perfectly for the size that was needed, and the fines come out there and carry on. There's the conveyor belt going back up to feed the bin, and here are the controls on the top of the flotation circuit down the bottom. This little very narrow gauge track is used to bring in the reagents which are used in the flotation cell. So here's a bit more detail. Here's the secondary rod mill, which is similarly designed. There's one of the electric motors. There's another electric motor for the smaller mill. Here's a guy oiling the bearings. And here's the flotation circuit panels, cells underneath. And once you leave the concentrator, you carry on, and you can see here you're getting close to the smelter because there's an awful lot of dead wood here, there, and everywhere. And of course, yet another creek. And here's the smelter, and here's the backdrop that I particularly like, with the mountains in the mist in the background, with still snow-capped even in July. And here are the totally bare trees, what are left standing. An awful lot of them have fallen down, and a lot of them, of course, were cut down to make all this cribbing to build the smelter on the hillside. Here is one of the scratch-built cars. This was used to carry the slag out of the smelter furnaces and to tip it onto the slag pile, which actually dropped into the ocean. So that was pushed by one of the little switches. And that is totally scratch built out of brass, with the exception of the San Juan trucks. Everything's got San Juan trucks. There's the slag pile. And if I ever get rid of some more filing cabinets out of the office side of the room, then I'm going to expand the slag area for two reasons. One is there was more trackage on it, including an interesting reclaimer. And secondly, there was a golf course on it. It was a black golf course, not a green one. And the tees and the greens were all sort of made in special little wooden boxes areas. But they used to have a ladies' golf club that played there every Tuesday afternoons. And I'd like to reproduce that. Now we get to the switchback, which takes you up to the upper level. This is the high line level there. And this is the tail track between the zig and the zag. This switch stand here is for appearance because it's actually an automated switch tortoise machine underneath it. And here you'll see the controls. There's the low line going to the slag pile. Here is the zig and the zag going up with the with the tail track there, goes back up to the top, and this is the high line which goes back to the concentrator. And this area has detectors on it, so that when a train, because there's a bunch of filing cabinets, which means going for a 50-foot walk to get to see when your trains reach that end, what you do is you basically run the train up until the lights change, and then it'll automatically stop. You just throw the reverser switch and it'll start up again and go back up the hill to the top. There are more simulating the other panel on the top left. 2 switches for the lights. There's a flickering light in the furnace, and there's an overhead crane which can't actually automatically run along the length of the smelter, but it appears to. And then there's a sound module, which is an actual recording of a smelter that I made up in northern Quebec, which has all of the warning signs and the moving crane, the slag pouring out of the smelter furnace and everything. We're up on the upper line now. We're back into that burned off area. This building here was where the original high-grade ore was bottom dumped out of these cars and went down and into a chute which fed into the top of the smelters. And once they stopped bringing the high-grade ore from the mine and they started feeding concentrate from the smelter, from the concentrator, they would bring the concentrate up here and they would still dump it in the same way. And here you'll see number 10 has now had its midlife repair, and it's now been repainted and it's labeled the Granby Railroad. And at the same time, it actually acquired an air pump and all sorts of other little subtle details, headlights, and it also got DCC sound. And here's a rake of cars. This was the standard ore car that they used. And here's another of the big trestles. And this eventually will be a rake of 8 ore cars, which was the standard length of train. So it pulled 200 tons each time. And so that meant it had to do 5 train loads a day to get 1,000 tons. And this then went up to the mine itself. And I built one module just to represent the mine, where here is the end of the 3-foot gauge line and the electric track, and here is the 2-foot gauge mine that comes out of the mine itself, and there is an underground electric loki and side dump cars which shoot down this chute into these cars here. Now you'll notice on these cars, they have a walkway on one side and a handrail, and the other side they have 2 sort of rather chunky mechanical devices, and I'll go into detail on that a bit later. The locomotive fleet comprised probably 4, maybe initially more, 040 saddle tanks, and I started by acquiring some second-hand Grantline Chemtron kits or badly damaged kit locos, which people had assembled or not assembled. And I'm afraid to say I thought it was a bad design, and I've given up on them other than as static displays. I've got 2 060 saddle tanks, which were bought by the mining company new, and they were essentially backups to the electric trains and for use where they had to go off catenary. One of them I converted from I acquired the mechanism of an Overland 260 at a narrow gauge convention. It didn't have a shell. Don't know what it was originally, but anyway, it was a lovely Overland model. So I wanted essentially the mechanism, took off the front pony truck and built the scratch body on it, which of course is unique to that area with the cabs. And then I completely scratch built both of the steeple cab electrics. Sorry, that's not quite true. One of them is fully brass, The other one is brass subframe and 3D printed shell. And a friend volunteered to do the 3D printing, and he spent an awful lot of time, and he did a fantastic job eventually. But it was a painful wait. I only have one electric locomotive underground, which I actually acquired an SN3 diesel from Russ and converted it to ON3 2-foot gauge and used it as an underground loco, which it looks terrific as. About half of the locos have sound. So here's on the left, you'll see the 3D printed shell. I mean, look at all the detail with the rivets and the hinged panel and the sand hatch there, another sand hatch there. This was an early version because the windows were too long. He had to modify it and redo it. And these end sections lift off so that you can either reach the decoder or put weights in or whatever. And this is the one which was all scratch built with brass. And that was the air tank. Interestingly, even though they ordered these locos in 1912 for delivery in 1914, the engineers determined that the whole railroad would be done with air brake equipment. None of these old-fashioned dubious braking systems. And here's the overland subframe in there, and here's work proceeding on the chassis, on the shell. And here's some of the 040s. These are two of the Grant Line Chemtron ones, which, as I say, they're okay as statics, this one in particular, but they both got broken frames, and I have not been successful in following Bob Brown's article from many years ago as to how to replace a frame with a brass piece metal. So then I acquired this resin casting from somewhere in the UK and thought I'd try and build one like that. It's great. This mechanism I picked up in the UK as well. Really nice, but the wheels are way too big. So that one got put on the shelf, and I'm working on another option right now. Here's the other side of one of the ore cars, and you can see the mechanism there. And this was so that when it ran into the unloading bin there, there was a mechanical device which came out and slotted into this hole, locked into a collet and rotated it in order to open the bottom dump doors automatically. However, if you've come 3 miles down in a snowstorm in winter, you've filled the ore up with snow, which probably is frozen as well, so that when you get in here, you don't end up with the ore neatly dropping out. So that's why you have that walkway on the other side, so the guy can get up there with a crowbar and bar down the frozen rock, which didn't free fall. So here you see the two sides of the car, right? The worker side and the mechanical connecting side. And here's one of my homemade log cars. Again, I'd seen pictures of these very simple log cars that they used, and I just figured, well, you can knock these things up in brass in no time flat, and if you use the right channel girder, then it's exactly the right size for a KD coupler box. And there's the more detail of the slag car, which had a wheel here that you could crank. There was a big gear and chain, and that in turn drove a worm, which then rotated this, so that eventually you could dump the God knows how many hundreds of gallons of liquid molten rock off the side. And the third and the other critical type of cars that they used were flat cars. And interestingly, they initially bought a fleet of the standard 26-foot long, 3-foot gauge Pacific Car and Foundry off-the-shelf cars. And within a year, they had bust all of them. And of course, the reason was that with 26 feet long, when the diligent workers loaded them, why would you only put 80 ingots on when you still got 3 feet empty at each end? So they would think, well, it's more efficient to put 100 on or 110. So they did. And of course, that meant that it wasn't carrying 25 tons, it was carrying more like 35 or 40 tons, and they all bust in half. So then they bought a second batch, which were only 18 feet. And I found that Mount Blue model has made an 18-foot 6 car, which worked very well. I then built these racks to hold my copper ingots, which are actually sheets of lead painted with copper paint. And these are marvelous because you can just lift the whole thing off and function as weights to keep the flat cars on the track. Sound modules. I was at one of the conventions, probably Sacramento, and there was a gentleman from California who runs a company called ITT Sound, and he was selling these little chip circuit boards, which had things like seabird sounds and a couple of music ones. So I bought 2 or 3 of them, and I brought them back and fiddled around and figured out that I could buy a 2.5-inch speaker for $3, and it fitted inside an empty Maxwell House instant coffee jar, and then you could bolt the thing right underneath the module surface, and it worked like a charm. Then I got back to him and said, well, look, this is working well. Can I send you some sound recordings and you pre-code it onto one of your chips for me? So then I got into doing the overhead crane in the smelter and the sound of a crusher in the concentrator. So I now have sounds everywhere, and it's great fun. I like it. Certain of my visitors hate it. It just said, "Oh, for God's sake, turn them all off." Nobody likes sounds, and that's pretty well the end of it. And this is actually a real scene. I didn't model this, and it's the cemetery at Anyox. It's a little bit up the hill, and you can see all the trees have grown back in again. But what I found fascinating was that so many of the graves had these First World War soldiers' helmets on them to mark every grave where one of the workers had gone to the war and not come back, and or had come back and had died subsequently. And when you think that this was an essential industry churning out more copper than anybody else for the war effort, yet even these people volunteered to go to the war. So what do I still want to do? Well, when I get rid of some more filing cabinets, I want to add another module to the dock so that I can extend it into deep water. I can build the coke plant, and I can build a 3-track section of the dock rather than a 2-track section. I want to extend the slag dump. I want to finish building the brass ore cars to complete the 8-car train. I've actually, I'm working on the 8th now. It's in the brass shop or the steel foundry, and car number 7 is in the paint shop. So they're coming along. I want to finish building my scratch build 040 switcher saddle tank, and I want to complete installing mood lighting to enhance the localized feature lighting. All of the buildings do have lights in them, so if you turn all the area lights off, you get quite a good night scene effect. And then there's a few more details. I want to add the the hydroelectric plant penstock pipes. I want to build turbines to put in the power station. And I want to make a second YouTube video. There is one of them, which if you Google Anyox Cab View Video 1, all no spaces, you'll see a camera on the front of a loco running around the length of the track. And here's a few of what I say, acknowledgements and names that I couldn't remember. Particularly Western scale models. Bill was critical in providing so many of those electric motors. Crusader Rail Services, sadly, they have gone out of business now. And Schomburg scale models, which are also out of business now. Plus the sound module. And then of all of the people who worked on this with me, Harold Kemp deserves the most praise, because he's 49% of it, if I'm 51% of it. I think that's it.